Hello Bobcats. In this video we're going to practice mole conversions. So I'm going to go ahead and get started. The first thing I like to think about is drawing a pathway of what I need to be doing to do the conversions. So I do realize it says how many moles of helium are in a party balloon that contains 2.74 times 10 to the 23rd helium atoms. So I am going to go from atoms to moles. I need to get to the mole. Now I do know that my conversion factor equality statement is 1 mole of anything is equal to 6.022 times 10 to the 23rd, in this case particles, which are going to be atoms. Okay, so I need to convert, and I can use this conversion factor. Now you need to get in the habit and get used to writing what are you looking for. I am looking for the number of moles of helium, and yes, it is important to include both the measurement and the substance as your units now. It'll help later when things get a little bit more complicated. So I start out, I know that I have 2.74 times 10 to the 23rd atoms of helium. And I know when I look here, my helium is the same unit, same substance, so I don't need to worry about that, but I need to take atoms to moles. And we know that I can do this through this equality statement. So if I have atoms on top, I'm going to put the 6.022 times 10 to the 23rd atoms of helium on bottom. And we know if we have that many atoms of helium, we have 1 mole of helium. Okay, so now I've got moles of helium, that's what I'm looking for, so I just take the top number divided by the bottom number. So I need to do these, I haven't done this ahead of time, apologize. So that's going to be 2.74 EE 23 divided by 6.022 EE 23, enter. And I know I want 3 significant figures, so I'll put 0.455 moles. 0.455 moles of helium. So that's a mole to particle conversion, or particle to mole conversion. The next thing we're going to look at is what does it mean when we have to go from one substance to another. If you'll notice here in the next problem, what I see is that I've got moles of this calcium carbonate, but I want oxygen atoms, so I've got to go from moles to atoms and oxygen to calcium carbonate. Now the only way that I can go from one substance to another, in other words oxygen is different than calcium carbonate, is I can only do that through a mole to mole ratio. So I have to be in the mole. You have to do it through the mole. So let's do our pathway first. And so we start out with atoms of oxygen. Now I don't want atoms of oxygen, I need moles of oxygen before I can go to the next substance. So I'm going to convert atoms to moles, and that's going to be moles of oxygen, and then I'm going to convert moles of oxygen to moles of calcium carbonate. So I got to use Avogadro's number to convert from atoms to moles, and then I'm going to use the mole-mole ratio to convert from one substance to another substance. So I'm going to go ahead and start with my question. I want to know how many moles of calcium carbonate. When I start with 4.25 times 10 to the 22 oxygen, or atoms of oxygen. I should put atoms here, oxygen, sorry, because that's the way I've been writing it, atoms of oxygen. Now I need to go from atoms to moles, and the equality statement that goes from atoms to moles is this up here. 1 mole is Avogadro's number. So since I have a big number here, I'm going to do it again on the bottom. 6.022 times 10 to the 23rd atoms of oxygen is 1 mole of oxygen. Okay, so now I've done this first conversion, and so this first step here is my Avogadro's number conversion factor. 1 mole is 6.02 times 10 to the 23rd. Now, I've got the mole, which is what I'm looking for, but now I got to convert from oxygen to calcium carbonate. And I can only do that through a mole-mole conversion. Now, we know that if this is a molecule of calcium carbonate, this is also, we can think of that, if that's 3 oxygen atoms in this formula, then that's 3 moles of oxygen for every 1 mole of this. So I say I've got 3 moles of oxygen, and I put oxygen on the bottom because it was on top here, is equal to 1 mole of calcium carbonate. We just use the subscript to get this ratio. So there's mole to mole ratio. Now I have moles of calcium carbonate. I ran out of space, so I'm just going to put the answer down here. Again, I need to do it on a calculator. It's probably good for you to see it. I do realize that this is a graphing calculator, and you don't get to use this on your exam, but this is the only one I have available for me right now. So let's clear that. We're going to have 4.25 EE22. Now, I'm not going to multiply by 1, so I'm going to divide by, so I hit divide by 6.022 EE23, then divide by 3, not multiply by 3, but divide by 3, enter. And I want 3 significant figures, and so when I look at this, this will be 0.235. So I have 0.0235 moles of calcium carbonate. Okay, so there's that one. Now we've done what this is particles to moles or moles to particles, both of them. In one case it's straightforward, the other one we have to convert from one substance to another using mole-mole ratio. Now let's convert moles to mass or mass to moles, and we have to use molar mass. So the first thing I want to do is go through my pathway of conversions, and so I'm starting out with moles, and I have to go from moles to mass because this is milligrams, but we have to remember that milligrams is a mass, and molar mass is in grams per mole. So I got to go from moles to mass, which is in grams, and then from grams to milligrams. And since it's the same substance, I'm not going to worry so much about the substance. Now, but I do know that this is moles to mass or molar mass. So I have to figure out the molar mass of sodium chloride. So sodium chloride is equal to 1 times 22.99. That's the molar mass. I got that from the periodic table of sodium right here. Sodium is 22.99. And I'm going to add the 1 times chlorine, which is 35.45 grams per mole, which is right here, chlorine, 35.45. So when I add these up, that comes out to be 58.44 grams per mole. Now, this is an equality statement if you think about it. I know I write it like this, but we're really saying that it's 58.44 grams is equal to 1 mole of sodium chloride. So it's an equality statement. So I can use this as a conversion factor. So let's go ahead and get started. The first thing is I've got to go, I want to know how many milligrams. So I'm going to write question mark. I want to know how many milligrams of sodium chloride when I have 1.05 times 10 to the negative 3 moles of sodium chloride. Now I notice here I've got the same substance, but I got to go from moles to mass. And to go from moles to mass, I'm going to use molar mass. Moles to mass is molar mass. So, and my molar mass is 1 mole is this mass. So if I have moles on top, I'm going to put 1 mole of sodium chloride on bottom, and that is 58.44 grams of sodium chloride. Moles cancel. Now, I'm not done yet though, because I have grams and I need to get to milligrams. So we got to do a grams to milligram conversion. So we know that the grams are larger, so 1 gram of sodium chloride is equal to 1,000 milligrams of sodium chloride. Okay, grams to milligrams. Now grams cancel, and so now I'm looking for milligrams of sodium chloride. That's what I've got. Okay. Now right away I notice, and I try to do things so I don't have to do a lot of calculator work. I notice that 10 to the third and 10 to the negative third, those two will cancel out. So really it's just 1.05 times 58.44. So we got 1.05 times 58.44, enter. So that's going to be 61.36, well I only want 3 sig figs, so it's going to be 61.4 milligrams of sodium chloride. Okay, so we're going to do, we got a couple more here to work on. The first one I would like to look at now, so we've done particles, we've done moles to particles, or particles to moles. Then we've done moles to mass, or mass to moles using molar mass. Now we're going to do what we have here, moles to volume, or volume to moles of a gas at standard temperature and pressure. Okay, so let's do our pathway for the conversion. And in this case, we start out with milliliters, and I've got to get to moles. Now, molar volume, remember the equality statement for molar volume is that 1 mole of any gas, doesn't matter what gas it is equal to 22.4 liters of that gas at standard temperature and pressure. Okay, so I need liters. So if I'm going to get to the mole, I have to have liters, but I have milliliters. So I realize here that I got to go from milliliters to liters, and then from liters to the mole. And this is a metric conversion here, and then we're going to use the molar volume conversion. So this is called molar mass. Moles to mass is called molar volume, moles to volume. So let's go ahead and get started. I want to know how many moles of sulfur dioxide of SO2 if I have 1,650 milliliters of sulfur dioxide. Now remember, I'm doing the sulfur dioxide the same, so I don't have to worry about substances. But what I do have to worry about is volume to moles, molar volume. And molar volume is moles per liter, or liters per mole, I mean. And so I've got to get to the liter. So 1,000 milliliters, because it's a smaller unit, and I'm putting it on bottom because it's on top here, is 1 liter of that gas. Now I can go from liters to moles. So liters here to moles, remember that's what I'm looking for. And so liters on top, so I'm going to put 22.4 liters of SO2 on bottom. And then that is 1 mole of that gas, SO2. That's there. And so I'm looking for moles of SO2. I have moles of SO2. So I'm just going to take 1650 divided by 1,000 divided by 22.4. So and I want three sig figs here, because remember 0 doesn't count when there's no decimal. So I'm going to have 0.0737 moles of SO2 in that volume. Okay. Now the last one we're going to look at, we're going to have to do a couple of different kind of conversions on this last one. So let's look at it. Let me get a pen that's a different color. Now, if I'm going to figure out what I've got here, I've got a mass of sodium phosphate, and I want atoms of oxygen. So I've got to change my substances, and then I've got to go from mass to atoms. Now, so let's figure out what we have to do. Let's do our pathway of conversions. So I'm starting out with grams of Na3PO4. Now remember, anytime I'm not in the mole, I have to go to the mole. Go to the mole. Whatever you do, go to the mole. So I need to go to moles of sodium phosphate, and this is going to be a molar mass conversion. Molar mass conversion. Now I'm in the moles of this substance, and once I'm in the moles of a substance, I can convert to another substance. So now I can go to moles of oxygen, because it's a mole-mole ratio, and for every 1 mole of this I have 4 moles of oxygen. And then I can go from moles of oxygen to atoms of oxygen using Avogadro's number. Okay, so let's work through this one. Again, I'm going to start out, first thing is I realize I got to go molar mass, which means I need to determine the molar mass of Na3PO4. So that's going to be 3 times 22.99, that's the molar mass of sodium, plus 1 phosphorus times 30 let's look at what phosphorus is. I don't remember that one. Phosphorus is 30.97. So that's 30.97 plus 4 oxygen, so that's 4 times 16.00, and I get 3 times, let's click this, 3 times 22.99 plus 30.97 plus 64, enter, and that's going to be 163.94 grams per mole. Now remember, that's an equality statement that says that 1 mole of this substance has that mass, is equal to that mass. So let's go ahead and do the problem now. I'm going to go through it. I'm going to start with my question mark. I am looking for atoms of oxygen, so atoms of oxygen, and I know I have 305 grams of sodium phosphate. Now I can go from, remember, I can't convert anytime I'm in a different, if I'm not in the mole, the first thing I'm going to do is go to the mole. And I already wrote that up here, but I keep saying it. If you're not in the mole, go to the mole. And since this is mass, I'm going to use molar mass. And so we have 163.94 grams of Na3PO4 is in 1 mole of Na3PO4, sodium phosphate. So this is molar mass. 163 grams, 163.94 grams is equal to 1 mole. Now I can go from, from moles of this substance to moles of oxygen. So we know that for every 1 mole of Na3PO4, and there's a subscript here 4, so that means there's 4 moles of oxygen. And the last part here is that I can go from moles to atoms using Avogadro's number. Moles of oxygen to atoms of oxygen. And remember, I'm already in that substance unit. So we got 1 mole of oxygen. It has 6.022 times 10 to the 23rd atoms of oxygen. Moles are gone. So now I just have to multiply and divide, and I'm going to do that very quickly here. So we've got 305 times 4 times 6.022 EE23 divided by 163.94, enter. And so I get, in my calculator, it says, whoops, I'm trying to get it so you can see this. It reads 4.48, and don't forget, times 10. Sometimes students forget to go all the way over here and see that it's times 10 to the 24th. So 4.48 times 10 to the 24th atoms of oxygen in 305 grams of sodium phosphate. Now, and you got to kind of think about this. If you didn't put that times 10 to the 24th, can you have 4.48, a fraction of an atom? No, you can't. So you need to think about your answers and make sure they make sense. And so I will stop there with practice on mole conversions. And good luck, and we'll see you later.